So the good news about this lab is the procedure is very, very similar to the one we did with speed and radius, right? All that's going to change is instead of changing the radius, we're now going to change the centripetal force. And we're going to change that by changing the hanging mass at the bottom, all right? On the last lab, that mass was always 100 grams or 0.1 kilograms, and now we're going to alter it to be different masses so that gravity pulls on it and puts more tension in the string and blah, 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 okay? So that's what we'll be changing, okay? And then we'll be obviously recording the same things we recorded in the last lab. We're going to be recording the time for 20 revolutions, using that to calculate the period, using that to calculate the speed, all right? So we're going to have a few responding variables, okay? We just need to be ready for that. And then you guys need to come up with your 3 controlled variables, okay, in the lab here. Okay, so for our hypothesis, remember if, and then statements, okay? The if part needs to talk about the relationship between centripetal force and speed. Not the other way around, because it's different going the other way, okay? We know that speed has an exponential relationship with centripetal force, but that is not true in reverse. So you may have to look at what type of fit fits best on your Google Sheet graph when you build it, to determine what the relationship might be. So it's okay if you have the wrong relationship in your hypothesis, as long as after you've done the lab and created your graphs, okay, that you in the conclusion write the correct one. Okay. Everybody with me there? Yes? Okay. All right, so that's what the if part's got to talk about. And part describes the experiment as always. Okay, in the then part, talk about what's going to happen to speed as centripetal force increases. Okay, that's what we want to see. You're predicting essentially the results here. All right, so like we said, we're going to start out with a 50-gram mass, okay, on the bottom end of our apparatus, okay, and we'll have the rubber stopper on the other end, and we'll have 40 centimeters as our radius, okay, and it'll be 40 centimeters throughout the entire lab. So put that mark on the string and make sure you keep it at 40 centimeters all the time. Okay, the masses that we're going to use, okay, what did they say here? Right, 50, 100, 150, 200, and 250. Okay, those will be ours. So we're going to increase by 50 grams each time. Okay, we're doing another trial. Okay, so you can just punch those in. And then same as before, do your time for 20 revolutions, do it twice for each mass, calculate average time, period, speed, and centripetal force. Now, when you're calculating centripetal force, don't calculate it this way. That's using our data. We don't want that, okay? Think about, again, what's providing the centripetal force here and calculate that force, okay? All right, so yeah, after that, pretty much the same as the last lab, okay? Now your analysis questions, okay, very similar. So first 3 are just filling in your chart. Number 4, also filling in your chart that tells you how to calculate centripetal force on this one, okay? Plot one graph of speed versus centripetal force, okay? And that's it. It says here to plot a second graph of speed squared versus centripetal force. Don't do that, okay? Just plot speed versus centripetal force, just the one graph. Okay. That's question 5. All right, and then question 6 is asking what's that relationship. I would like an explanation there as well. Okay, don't just write one word. Okay, I'd like an explanation on that. Okay, conclusion, copy paste your hypothesis, accept, reject, 2 sources of error, ways to fix them, probably similar / identical to the sources of error from the last lab, in that the procedure is basically the same. Okay, it's going to have the same sources of error as the previous lab did. So you can save yourself a little bit of time there and copy and paste those sources of error over. Okay. All right, any questions on what we're doing? Everybody's good? Okay, have at her.